In example 4, we want to simplify the following expressions. In part A, we have x cubed times x to the fourth. We can use the product property to come up with this result, but let's take a look briefly at why that property works. X to the third power is the same thing as x multiplied by itself 3 times, and x to the fourth power is the same thing as x multiplied by itself 4 times, which means altogether we have x multiplied by itself 1, 2, 3, 4, 5, 6, 7 times. That's exactly the same thing as x to the 3 plus 4 power, and that's where that product property comes from, and where these other properties come from as well. We can demonstrate them similarly, but all we have to do when we have x times x is just add those exponents together to get x to the seventh in this case. In this case, we have u as the variable, but the property still holds. To combine this, we can rewrite it as u to the 6 plus negative 4 power, or just u squared. In part C, we have s to the negative fifth times s to the third. So this will be x to the negative fifth plus 3, which will give us s to the negative second power. But that can't be our answer in this case because we have an added direction that we want to write this using only positive exponents. So what we'll do in one last step is use those properties of negative exponents to take that s to the negative second and move it down to the denominator, which flips the sign of that exponent. So x to the negative second power is the same thing as 1 over s squared. We're just rewriting it without that negative exponent. And then in part D, we have v squared times v to the negative second. We're multiplying two variables raised to powers. So we'll add these together. So this will be 2 plus negative 2, which will give us v to the 0, or just 1, because any value raised to the 0 power is exactly equal to 1. In example 5, we want to do the same thing, but now we have expressions where our values are being divided. So we'll be using the quotient property. In this case, we have b to the third power, and even though it's not written in the denominator, that's b to the first power. So this would be the same thing as b to the 3 minus 1, which is equal to b squared. In part B, we have x to the third over x to the third. We might recognize that any value divided by itself is 1, as long as that's not a 0 in the denominator. But we can also write this out as x to the 3 minus 3, which gives us x to the 0, or 1. In part C, we have t to the negative 1 divided by t cubed. So this will be t to the negative first minus 3, which will equal t to the negative fourth. But again, we want to write this using only positive exponents. So we'll flip that and put that t to the fourth in the denominator, which changes that exponent from negative to positive. And then in the last example here, we have r squared divided by r to the negative fourth, which will be r to the 2 minus negative 4, or r to the 2 plus 4. So in this case, we end up with a positive 6 as that exponent, and our final answer is just r to the 6th power.